Okay, so hello everyone. This is our very first webinar about the reTHINK project. This one is dedicated to TADHack. So the idea is to introduce the reTHINK framework and the different resources that we are making available for TADHack participants to explain them how to use them on making some nice hacks. So we have here Anton from Quabis, Stefan from TLabs, also Luis and Vitor in Aveiro that will also support us in 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 our webinar. Someone else is joining, I don't know who. So let's start. So what is the reTHINK project? So the reTHINK project is we are developing our open source communication framework. We are funded by the European Commission, and the idea is to look on the best practice from web players and telcos, and try to develop something that can really take advantage of state-of-the-art in terms of web communications. So we are aware, telcos in particular, that web players are much more agile, and actually they are really leading innovation for communications. And so in reTHINK, we try not to reinvent the wheel. So really try to do the best, try to use the best practices. And but at the same time, we also know that there are a few problems with the approaches that web players are using. For example, if I actually to be in contact right now with my friends and also my colleagues working with me, it's really a mess, because if I have a look on the different applications that I have to use, so this is just an example of the different applications that I have in my smartphone to in order to be in contact by messaging or by multimedia conversations, and it's really very difficult to manage all these applications, the different accounts that I have for these applications. And the reason for this is that the different players that are providing these applications. So now I'm going to show you one slide. So hope that you can see it. Yes. So this slide tries to illustrate the problem that is having these web players having a walled garden model. So this means that users using different services are not able to communicate each other. So they are really locked in these walled garden. Also, these web players are changing the data of the users. So if the user from one player to another, they really can't. So this is one of the biggest problems that we are facing. And in reTHINK, and we can also think about this as like a black hole, where smaller players that emerge in the market can't really survive. The only way to survive currently in the market is to be big, real big. We have to have like hundreds of millions of users in order to survive. In reTHINK, we are introducing a few new concepts and a new service paradigm that we call Hyperties, that are inherently interoperable. So this means that the different providers using Hyperties can very easily interoperate each other without having to standardize protocols APIs, as we're going to see later. And if there is a new player in the market, even if it's really small, it will immediately be connected to the global network of reTHINK. So in this way, they can survive without having to be very big. And in terms of the user's data, we also separate the service providers from the service providers, in this case, identity providers, managing the user's data. And so users can decide who are the ones they trust in order to manage their private data or identity. And for that, what we propose is that in order to interpret, services only have to agree on the data format. And in this case, we are using JSON schema to define the data format formally. And there is no way, no requirement to standardize the network protocols or the service APIs. Only the data format has to be standardized. And then services communicate each other through synchronization. So there is, in this case, one hyperty that we call the reporter that has permissions to write in some JSON data object, and all changes that are done in this object will be immediately propagated to remote observers hyperties. So that's the way how hyperties communicate, interpret each other without having to standardize protocols or APIs. So this is, we're not going to go into details. We're going to provide you the links to learn more about the different concepts and mechanisms that are behind this. We're now going to move to a few demos. So I will now ask Stefan to make a short demo. In this case, it would be a WebRTC demo. Stefan?
Yeah. Can you hear me?
Yes, very well.
Great. I hope everybody else can do as well. Okay. Yeah. Paulo mentioned reTHINK is there to allow communication between domains that not necessarily know each other in advance. The only thing they need to know about each other is the kind of data they are operating on. As long as they are using the reTHINK framework, they should and they should be and they are interoperable. I'd like to show it with an example from the WebRTC world. What we are trying to do is to establish a call between Paulo and myself. That means between Portugal and Germany at this point in time, by using different implementations of WebRTC applications. Different implementations of the Hyperties that Paulo was mentioning, but they have agreed on a certain data format. So, Paulo, perhaps you start your application first.
Yes, I will now share my screen. So just a second. Okay.
Paulo is doing now. What Paulo is doing now is he loads an application via a normal web link. And what we see here is the so-called Hyperty toolkit. It's a kind of framework that facilitates and supports the development and testing of Hyperties. So this one is hosted on a domain that's called rethinktlabscloud.com. And what he does here is he selects an identity from a third-party identity provider. In this case, it's Google, that this new Hyperty that he's going to instantiate is attached to. So this Hyperty is now loaded to the browser. It was registered in his domain. It got a unique address. You can see it here as the Hyperty URL. And this Hyperty URL is now registered in his domain. So at this point in time, this Hyperty is accessible from the outside world. Paulo, if you switch over to my screen now, I show you the a second type of application. Okay, done. Can you see my screen?
Yes.
Great.
But not deployed yet? Yes,
No,
okay.
I'm just doing it. So I'm starting a second type of application that looks different. It's a completely different implementation. It uses a different Hyperty, but the concepts behind are the same. Also here we got a unique address in a different domain, and the Hyperty that we have instantiated is registered to our domains registry. Now we got two applications running, one in Paulo's domain, one in my domain. What I'm doing now is I'm trying to search for Paulo at his domain. I hope I don't spell here, at gmail.com. What we see here is kind of a temporary solution, because later on this very detailed search will be replaced by a discovery component that allows us searches like, I'm looking for Paulo, who's currently sitting in Lisbon and he's attached to this or that company. At the moment, I have to put in the domain I'm going to search in. And if I do it, then the registry in his domain is requested to give us an address of a Hyperty in his domain that I can call. And I will do it right now. So I will send a WebRTC call to Paulo. I'm waiting for the answer. Paulo is now requested to press the accept button if the call comes in. Oh, it seems to take a while. Paulo, can you see the request coming in?
No, okay, we got...
So it seems that we got a small problem. So I'm trying to repeat it. So we got the Hyperty. I'm sending the request.
Okay.
Now we can see the call coming in. Okay, something's going on, and at the end we have this established WebRTC communication. I'm not sure which screen you are seeing now, but perhaps, Paulo, you can switch between the two.
Yes, so this is my screen, and I will going to... Yes, this is your screen.
Okay, we can hear an echo now because we have two connections open at the same time, but you can see it works. We have two different applications connected to each other, and these applications just and only share the use of the reTHINK framework and the knowledge of the data model that both applications are using. That's it also already for my presentation. I will hang up and give back to Paulo.
Okay. So now I will move.
Oh, here. Hung up.
Yeah,
okay.
You go. So now just a second demo, very quick one. So now we're going to also show how we also support other use cases, not just the WebRTC calls. Let me. Yeah. So now in this case, I'm going to use a group chat Hyperty on my side, and so I will move now to another test bed. Let me show you my screen. Yes, in this case, it's our iBroker test bed. I will load the group chat manager Hyperty. So it's asking to select an identity. So I will select my Google identity as I did for the WebRTC demo. Here it is. So now I have loaded the group chat manager Hyperty. Now I will ask Anton to do the same on another domain. So in this case, it's from Quabis. So this is another implementation of a group chat. The layout is very similar, but there are a few differences. This is really a different Hyperty that we are using for testing. As you can see, there is a different URL for the Hyperty. Yes, just that. And now I'm going to search for, let me show you, yes, for So I will create a new chat room. I will just call webinar chat room, and I will invite the participants. So in this case, I will put here Aton, Sophie, Aton, Romain. Aton, just correct me if I'm wrong.
Yeah, it's right.
Thank you. So in this case, I have to still to set the domain, but in future it won't be necessary, and I will invite him. So we go. Now, hopefully, now you see the screen from Anton in Corbis. Here you go. So Anton has just received my invitation and accepted, and he joined my invitation. And here I just received a message from him, and I can reply, and then we can exchange messages. Here we go. And on his side, he has just received. Yeah. So just a very quick demo on how we can also support interoperability between different group chat implementations running in different domains very easily. So let's move on. I will now, yeah, so just very two demos that very shortly demonstrates how interoperability can be supported in different use cases. Let me now just introduce you to our resources. So we are using GitHub. Let me show you. So if you look into GitHub, you just have to look for reTHINK projects, and there you find different repositories. We have created a repository dedicated to TADHack, where you'll find different links that will guide you to the different resources. There you can find links to demos, to the repository where you can find the hyperties that are available, so the source code. So you can see several hyperties that you can use for your applications. Also the documentation for these hyperties that explains the APIs to be used. And also you can find here then some quick starts for the development of hyperties. So here you can find, for example, how to set up the toolkit and how to use it to develop a low-world hyperty. In another repository, we explain how you can quickly start developing applications for using hyperties, in this case, the low-world hyperty, and also some short links for the hyperties that are available, and also tutorials. So that gives more details about the hyperty concept, how to develop hyperties, how to develop message nodes, and finally, the complete specification where you can find all details there. So you have a specs repository where we detail the architecture that we are following, the concepts like the protocol on the fly, the reporter and observer communication pattern. So all these you can find in this repository in detail. So I want to go now explaining this. I will just now show you very quickly how to develop a very simple hyperty, the hello world hyperty. So in order to develop hyperteas, we have this toolkit that Stefan already mentioned. So you should install by using npm. You have the link to the quick start to toolkit, where you have all the explanations about how to set up the toolkit. And then to start, you just have to type, in this case, run start dev. And then it will ask the place where you want to host your source, the source of your hyperteas.
Paulo, sorry, you should share your screen, I think.
Ah, okay, you're right, I forgot. Wow. I'll move this from here. Can you see it now?
Yes.
Okay. So yeah, I just type in the command to start the toolkit, and it's going to ask me for the place where I have the source code. In the meanwhile, I should also set in my hosts to use the local host for this domain. So I'm using the iBroker domain for my local environment. And so we should do this in order not to install all the reTHINK framework locally. So in this way, you can use at the backend our iBroker testbed. Okay, now the toolkit is asking me where should I host my source code. In this case, it's the dev hyperty. In order to have the possibility to select, you should ensure that this dev hyperty is at the same level in terms of the directories as the toolkit. So in this case, I can show you that yeah, the toolkit folder is at the same level as the dev hyperty folder. Okay, so now I select the dev hyperty. So it's going to now extract all the source code and generate the descriptors that the toolkit will require and publish in the catalog. So the catalog is the place where we're going to host descriptors and the source code of hyperteas. So we have a few hyperteas. So it's publishing the catalog. Now it's starting. Okay, so it's just started, and now I have the toolkit running. Now let me briefly introduce how to develop. So in this case, we have two hyperteas. So we have the reporter and the observer. So the reporter on the left and the observer on the right. And we have to define a common data object that in this case is the hello object that is defined in a JSON schema that you can find here on the right. So this is the JSON schema that defines the hello object being used by the hello world reporter and observer. This is very simple, so just define an attribute called hello, type string, and then the hello reporter can create hello world objects. For that, we use the syncer API. So we should instantiate one syncer component with this, where you pass the URL of the hyperty, the configuration, and also the message bus that's going to be used in order to communicate with other hyperties. Then we have one hello function, and there is the place where the object is created with the function create. You just have to pass the descriptor of the data schema of the data object that you are using. This has been defined here in the constructor. So this is the URL from the catalog from where you can load the JSON schema that defines the data object. In this case, it's this JSON schema. Okay. Now, in the create, you can also invite hyperties that want to be observers, and also initial data for this object. In this case, the initial data is this one on the right. So where the hello attribute has this string, hello buddy. Okay, so the object is created. So as soon as you invoke this function, on the observer side, you're going to, so the constructor has the same parameters, and there you also instantiate a new syncer, but in this case, you'll be the observer. So this means that we will wait for events about invitations. So the create function that was invoked by the reporter will trigger this on notification. And in this case, as soon as the create is received by the observer, it can acknowledge the subscriber, the reporter, that he receives the invitation, and then it can subscribe to be an observer for this new object. By the way, in this case, the observer also notifies the application that an invitation has been received. So the observer requests to be subscribed, so it just has to pass the descriptor of the object that you want to subscribe, and also the URL of the object. So objects are also addressed with URLs. This subscription is going to be received by the reporter on this function, on subscription. It's going to be called, and in this case, the reporter will automatically accept the request for the subscription. And now this means as soon as this has been accepted by the reporter, this means that the reporter and the observer has a data synchronization stream established between them. And as soon as there is a change in the hello object, like in this case with the by function, so in this case the hello attribute is changed, the observer will immediately will be immediately notified about the change with this function on change. And in this case, it will trigger the application about the change. So this is really the basic mechanism that is used for the communication between hyperties through data synchronization without having to standardize protocols or APIs.
Okay, so let's now have a look and test our hello world locally. So I will move to another screen. So in this case, we are using the iBroker backend. So that's what I put here. I have to accept the certificate. And I can just select the hello world reporter. I will associate to my own Hyperties. So at this point, I'm using the toolkit locally. If you check the console, here you can see also every time it connects, there is a change. Now I'll load the observer Hyperty in a second. Oops. I think I will close this one. Too many windows open. So I will open now the observer in another window, in another account. It goes. And now the reporter can invite the observer and say hello to him. It goes. So it says hello and it can say bye. And then if we make a change, so let me move now to my another screen. So just to show you that this really works, I can change here the bye message. And let me check. That I did change. Yes. Now I can test it again and to see that it really changed. So this is the reporter again. I'll put here the observer. If the change was set, you will see now a different bye message. So now we have a different message that you just changed in the reporter. So this is just to show you how easy it is to develop Hyperties with the toolkit. So you can also have a look on the application repository, where you can also see how easy it is to develop Hyperties. It's even easier. Before we close, just show you the challenges that we are proposing for TADHack. So if you have a look, let me share again the screen. So if you look to the TADHack repository, you'll find there our challenges. So we have two challenges. The first one is the simplest one, and the idea is to develop different applications by different teams using existing hyperties, and at the end demonstrate that they can interoperate each other, even if they're developed by different teams. The second challenge is a bit more difficult, and the difference is that you should now develop your own hyperties to be used by your applications, or you can also extend existing hyperties with additional features. So provide here some ideas, like having the possibility to delete or change messages that were sent by the group chat hyperties. Another idea would be to have a chatbot with some intelligence, but you are free to provide different hyperties with different features. It's really up to you. So I hope that you have fun with this. And later we're also going to provide a link to some surveys in order to have your feedback about the reTHINK framework in order to let us improve as much as possible. Okay, so see you next weekend, and I hope that you have fun. Bye.